Okay, so tonight, just going to go through my Arduino loft layout, the ideas, and converting over to LCC nodes. So for some who've already been, they've possibly seen some of this, so I do apologise, but obviously because it's going outside, I've put it back in. So previously, the layout was controlled using Arduinos with CMRI nodes, and then using JMRI as the master controller. Now, the layout's 24 by 24. There's an upper level, which is, so hopefully you can see my mouse, is a roundy. This section here has still to be built because under here is the lower station and I needed to do the scenic work on that. It's all going to be using Merg block detectors, the DTC2s and 8s for the block detection. And then it uses spot detection. So every one of these is a separate block. I have tied in the turnouts to that section of the block. Now I've done that because I didn't want to put extra blocks in, and I'm not going to be using dispatcher because I'm going to be using scripting. So I can get away with it. With dispatcher, you have to have them sort of as separate blocks. Then it's every point here, there's infrared spot detection, which are the ordinary cheap modules that we can use. And they, because of where it is in the loft, I don't get affected by sunlight. So I've not had to worry about that side of things. So I say, compared to some of the layouts that LCC is designed for, which are very large layouts, obviously stateside and probably Australia and New Zealand maybe, this is not that big, and there's never going to be more than 5 or 6 locos doing either choreographed dances or me. I can only really run one loco. There's only ever going to be me up in the loft running it. So that's the layout. Obviously, my ideas changed due to not being able to alter the servo stored positions without modifying the sketch and uploading them again. Now, this was more down to my coding skills at the time because I didn't know how we could possibly do it. Obviously, within the Merseyside area group, Steve has been showing how we could do that using CMRI and different ways of doing it with encoders and everything. So, yes, that could have been done here, but because of the way I've set the layout up, I'm going to go now. So the issue I had is this is my Arduino CMRI node at the moment. And this is the RS485 module that I was using due to the issues with the R7. So this one has got a UART chip in it, and that made life a lot easier. But there was still an issue. If I needed to change the servo stored position for either end, closed or open, I had to unplug the Nano out of the shield, plug the USB lead in, change the 2 lines of code, re-upload it, put it back in, and was happy. Now that node there is controlling this section of the layout. So it's actually driving 3 2-aspect signals. It drives this turnout here, and then there's an infrared spot detector here, and then there's 4 in the station on the 2 platforms. So 2 on each platform. The block detection is done on a separate, that at the moment is done on a Arduino Mega, again using what's called CMRI, but that is coming out and that's going to move over to the new type of node. So I looked at the various other solutions like Arduino CBus, and that's where I learned some nice things with it. And then I also looked at OpenLCB. I finally decided to go with LCC and see what I could do with it for my layout. This has all been made possible with the thanks, with the help of David Harris. Obviously, he came on board when I asked could he possibly do me a sketch when we had issues, and it's moved on since then. I've learned a lot. I've still got a lot to learn though. So deciding on the right tools. So choosing the best microcontroller for my needs. I started with what I already had plenty of them. And I had plenty of these shields. I had plenty of Arduino Nano R3s. I looked at CAN bus on YouTube, and that's where I started playing with CAN bus. I thought, let's learn what CAN bus is. And I bought the MCP2515s. Now, on YouTube, people are saying you should be able to get 1,000 messages a second with it. So I thought, right, I'm going with that. Now it uses SPI. So these connectors here represent where it goes on the original Arduino Nano R3. But it then only leaves me with a number of pins. I won't use pin 0 and pin 1 because that is used also for when you're doing the uploads and whatnot. So I never like to use them. So I only had pins 3 to pin 9 and then pins A0 to A5 that I could do digital. But that was enough for CMRI. But obviously this works well now with what we've shown with David's original 2 servo NIO, which I sort of started pushing a little bit more depending if I was doing it standalone or whatnot. However, the MCP2515 is not the best tool. For larger layout or more complex layouts, with lots of traffic, really we want to be looking at using the MCP2518FDs. Now that would be a better choice. Now, we would need to look at the library to make sure it works with this, and I believe it should do, if I'm right. I think it's using the same pins, but obviously this one will offer us more first in, first out buffers and everything else. But for my layout at the moment, I'm not convinced at the moment I need to go to this. But because I am showing this outside, I'm making people aware, really, if you're going to make anything bigger than what I'm showing, you're probably better off buying one of these. It's only a small amount of money extra. It's not a lot. But obviously, the Nano R3, as we mentioned early on in some of the early forum threads, there was a lot of talk about, we are limited with memory. So for adding more functionality, we probably pushed the Nano R3 as far as we could. Now, if we were to do more hard coding and not use some of the configuration side of it, I could possibly just throw things onto the bus and read it and do different things with it. But that's not going to make it easier for the people I'm trying to aim at what I'm doing, which is give people examples that they can just download off GitHub, install onto their microcontroller and have a play. So we then started playing with the SP32, or I did with the Dev 1, which I had plenty of them spare from the previous projects I was doing, which was obviously using Wi-Fi for my fish tank. There's a small increase in cost, but it's, in my opinion, it's minimal. So it would be, you think, well, that's the way to go. Obviously, it's got a built-in CAN controller, but requires a CAN transceiver module. So I went with this module here, which is the SN65 HVD 230 for all my testing. And this has been successful. That's working well. The thing is, it is more complex to work with due to pin mapping and also boot up pin strapping. So that's been one of the issues I found with it. Certain pins, we were limited whether we could have them as inputs or outputs. We could get away with more of them for outputs than we could for inputs, but I think that was more because we're allowing people to choose either or. So if we'd have said you're going to use it as an input or an output, that may not have been a problem. So next we started, David started showing us the Arduino Minima, and I thought, right, okay, David was telling me how, it's got a lot more memory. It's got a built-in CAN controller. So me being a cheapskate, I went for this clone version of it because I like the fact that it's got the breakout pins. So that's nice for me with, connections up using DuPont. And I was picking these up around £4, so I like that. But then they brought the R4 Nano out. Now, I must admit, David had some made through one of the PCB manufacturers. So he had some made before they actually released the commercial one. Now, at the moment, this is a little bit, I'm not going to say it's expensive. It's about £13. So I'm still sort of hoping that obviously we require, a transceiver module, but it has got a lot more memory. And the thing is, in my opinion, hopefully soon the clones will come out for it. I'm hoping in the next year. That might bring the cost down to £4 or £5 a module. So this is the transceiver I'm going to be testing with it. I haven't actually tested the CAN side of it yet. But I've bought some of these. These will work on 3.3 volts supposedly and 5 volts, but these are 5 volts, so that will work. So the sketches will need some tweaks for the Nano, because obviously what we've got here, and as far as I'm aware from what I've read on the data sheet, we can actually now use pin 6, A6 and A7. So we gain pins there, and then we've also gained pin 0 and pin 1 as well. So where we're not using SPI, we're using 4 pins. We're going to drop down to 2 pins for the CAN transceiver. But we also gain this extra little connector here, which offers 3.3 volts for I2C. So again, I like this because it'll fit into what I've got. So that becomes another option for us to use. There is one other thing that I do like about working with the Arduinos compared to the SP32. The compile time is a lot faster for the Arduino Mega and the Minimas. Now, while I was away playing with the SP32s, it was taking a long time to compile stuff. Obviously, once you compile things, if you're not altering the sketch, it doesn't take as long the second time. Then the next thing, obviously, to get my layout up and running again, I've gone to the Arduino Mega 2560s R3. Obviously, a lot more pins. Again, I'm going to use this transceiver to start with. I've made this 3D printer just to hold it for now. I've got other PCB holders for the other modules as well. Now, at the moment, I've got 3 sketches available for this. And one, I think it's 48 or 63 or something, or 60 odd IO, or 60 odd, sorry, 60 inputs and about 60 outputs. But then we've just got this new sketch working, which is what I wanted, which I felt was more handy. I've got one where it's 24 inputs with various stages, so toggling and inverted and everything else, and the time, which I demonstrated in previous talks and videos on my YouTube channel. But then we've got the actions, which allows us to teach the output multiple events. So when an event comes on the bus, it could turn one LED on, another event comes in and it could make it flash. There's a lot more we can do with it. So that's sort of what I'm working on at the moment, to get that, up and running on my layout. So the next thing I want to work on is Wi-Fi nodes for simple animation. So we did the 2 servo 8IOs, and obviously I can push that a little bit either way. I'm going to be playing with that on the ESP32 Dev 1 board using Wi-Fi. Now, these will not be affected if they miss events, because obviously there was concern about missing events if you tied in with other parts, but as these are going to really just not be feeding back to JMRI, I'm not too concerned about that. So I think that's going to allow me to do a number of animations. So on my layer at the moment, I've already got some stepper motor animations. I've got mine lit going up and down in a mountain area, and I've got doors opening and closing. So that's something I will be working on soon to see if we can get that to work. So an action happening from maybe a train coming in to a platform will trigger the warehouse doors to open. Simple animations, and I think the Wi-Fi will come into play on that. And I'm also looking at using the Wi-Fi now for the levels crossing that we'd seen. So we've got the extra memory on the Mega, we've got the Wi-Fi, and we've got a lot more memory, and I think that's going to work well. Anyway, that's about me wrapped up, so I'll sort of see if there's any questions on what we've got, and if there's no questions, I'll move over